Welcome to this comprehensive guide on C-sharp null safety, a crucial concept for writing robust and error-free code. In the world of software development, encountering unexpected null values can lead to frustrating runtime crashes and unpredictable application behavior. This guide will delve into how C-sharp provides powerful mechanisms to proactively prevent these common null reference exceptions, significantly enhancing your application's stability, reliability, and overall user experience. We'll explore the tools and best practices that empower you to build more resilient software from the ground up, ensuring your code performs as expected even when dealing with potentially absent data. Null reference exceptions, often abbreviated as NREs, are consistently ranked among the most frequent and vexing runtime errors encountered in C-sharp applications. They occur precisely when your code attempts to access a member, such as a property or method, of an object variable that has not been initialized and therefore holds a null value. Imagine trying to open a door that simply isn't there. That's essentially what happens. This can lead to immediate application crashes, data corruption, or unexpected program termination, severely impacting the reliability and professionalism of your software. The landscape of C-sharp development significantly evolved with the introduction of null safety in C-sharp 8.0, primarily through a feature known as nullable reference types. This groundbreaking addition fundamentally changes how the compiler treats reference types, allowing it to perform static analysis and warn you about potential null issues at compile time. This proactive approach is a game changer, as it enables developers to identify and address null-related bugs during development, long before they manifest as critical runtime failures in production environments, saving countless hours of debugging and improving code quality. To harness the power of nullable reference types and enable this crucial compile time null checking, you have two primary methods. The simplest way is to add the hash symbol, open parenthesis, nullable, enable, close parenthesis directive at the very top of your C-sharp source file, activating nullability for that specific file. Alternatively, for a project-wide approach, you can configure it directly within your project file, typically a .xproj file, by adding less than, nullable, equals, enable, greater than, less than, slash, nullable, greater than within a less than, property group, greater than tag. Enabling nullability is considered a modern best practice for all new C-sharp projects, providing a robust foundation for safer code. By default, once nullable reference types are enabled, all reference types are treated as non-nullable. This means the compiler assumes they will never hold a null value, and it will issue warnings if it detects a potential null assignment. If, however, you explicitly intend for a reference type to be nullable, meaning it can legitimately hold a null value, you must explicitly mark it with a question mark suffix, such as string question mark, myClass question mark, or list of integers question mark. This clear distinction helps the compiler enforce your design intent and provides better clarity for other developers reading your code. The null conditional operator, denoted by the question mark, .syntax, is an incredibly elegant and concise feature designed to safely access members or elements of an object only if that object is not null. This operator provides a streamlined alternative to verbose if object is not null checks, significantly reducing boilerplate code and enhancing readability. It allows you to write more expressive and compact code while simultaneously preventing null reference exceptions by gracefully handling situations where an object might be null before attempting to dereference it. The true power of the null conditional operator lies in its short-circuiting behavior. If the operand immediately preceding the question mark, that operator evaluates to null, the entire expression on the right side of the question mark, is not executed. Instead, the entire expression simply short-circuits and evaluates directly to null, effectively preventing a null reference exception from occurring. For example, in user .address.street, if user is null, address is never accessed. If user is not null but address is null, then street is never accessed and the whole expression yields null. This short-circuiting mechanism makes the null conditional operator exceptionally useful for chaining multiple member accesses together, especially when navigating complex object graphs. Consider a scenario like order question mark, .customer question mark, .contact question mark, .email. Without question mark, This would necessitate multiple nested if statements to check each level for nullity, leading to deeply indented and less readable code. With question mark dot, each step in the chain is automatically null checked, ensuring that the expression safely evaluates to null if any part of the chain is null without throwing an exception. Furthermore, you can effectively combine the null conditional operator question mark with the null coalescing operator question mark to provide a sensible default value if the entire expression evaluates to null. This combination is particularly powerful for ensuring that you always have a non-null result. For instance, string street equals user question mark dot address question mark dot street question mark unknown will attempt to retrieve the street. If user is null, or address is null, or street itself is null, the entire left side of question mark becomes null, and the default value unknown is then assigned to the street variable, guaranteeing a valid string. Now, let's shift our focus to another important null safety feature, the null forgiving operator, represented by the exclamation mark. This operator serves a very specific purpose. It tells the C# compiler to treat an expression as non-null, even if the compiler's static analysis suggests it might be nullable. Essentially, you are making a firm assertion to the compiler, promising that the value will not be null at that particular point in the code, thereby suppressing any potential nullability warnings it might otherwise issue. While the null forgiving operator exclamation mark can be a powerful tool for specific scenarios, it must be wielded with extreme caution and a clear understanding of its implications. By using exclamation mark, you are essentially overriding the compiler's nullability analysis and taking full responsibility for the null safety of that particular expression. If your assertion that the value is non-null turns out to be incorrect at runtime, a null reference exception will still occur, bypassing the very compile-time safety net that nullable reference types provide. Therefore, its use should be carefully considered and justified. A common and appropriate use case for the null forgiving operator exclamation mark arises when you possess external knowledge or have implemented specific logic that guarantees a value will not be null, even if the compiler cannot infer this certainty through its static analysis. This often occurs in scenarios such as unit tests, where you might mock dependencies to ensure non-null returns, or after performing an explicit null check that the compiler's flow analysis doesn't fully track. It's also useful when dealing with deserialization or dependency injection where you know a value will be populated. For instance, if you have already performed a thorough null check on a variable, you can then safely use the null forgiving operator exclamation mark to assert its non-nullability without incurring redundant checks or receiving unnecessary compiler warnings. Consider an if value is not null block. Inside this block, you know value is not null. Using value exclamation mark dot to string within this scope tells the compiler you've handled the null check, improving code readability by avoiding casting or additional temporary variables, and ensuring the compiler doesn't complain about a potentially null value. However, it is paramount to understand that misusing the null forgiving operator exclamation mark can inadvertently reintroduce null reference exceptions into your codebase, undermining the very purpose of null safety. If your assertion of non-nullability is genuinely incorrect, and the value turns out to be null at runtime, your application will crash with an NRE. Therefore, always ensure that your confidence in a value being non-null is absolutely justified, backed by robust logic, thorough testing, or external guarantees, before employing the exclamation mark operator. Adopting best practices for null safety is crucial for writing high-quality C# code. A foundational practice is to always enable nullable reference types in all your projects, especially new ones. This can be done by adding less than, nullable, equals, enable, greater than to your .exproj file. By doing so, you leverage the compiler's powerful static analysis to catch potential null issues at compile time, transforming what would otherwise be runtime errors into actionable warnings that can be addressed proactively, significantly improving the robustness of your applications. Another critical best practice is to consistently validate inputs to your methods and constructors. This is particularly important for public APIs or any code that receives data from external sources or other parts of your application. When an input parameter is expected to be non-null but receives a null value, the appropriate action is to throw an argument null exception. This clearly communicates to the caller that invalid data was provided, preventing unexpected behavior downstream and enforcing the contracts of your methods. To handle nulls gracefully and avoid abrupt application termination, make extensive use of the null conditional operator question marked for safe member access. This operator is invaluable when dealing with objects that might legitimately be null, such as optional configuration settings, database query results, or properties of complex data structures. It allows your code to proceed smoothly, evaluating to null rather than crashing, and provides a clean, readable way to navigate potentially null object hierarchies without verbose if statements. While powerful, it is essential to avoid overusing the null-forgiving operator exclamation mark. This operator should be reserved exclusively for those rare situations where you possess absolute, undeniable certainty that a value is not null, even when the compiler's analysis cannot confirm it. If there is any doubt whatsoever about a value's nullability, it is always safer and more robust to employ explicit null checks, the null conditional operator question marked, or other null handling mechanisms to maintain the compiler's safety guarantees and prevent potential runtime exceptions. Beyond the null conditional question mark dot and null forgiving exclamation mark operators, C# offers a rich set of other null-related features that contribute to comprehensive null safety. One such feature is the null coalescing operator question mark, which provides a concise way to define a default value for an expression if it evaluates to null. For example, string result equals maybe null string question mark default will assign default to result only if maybe null string is null, offering a clean alternative to a ternary operator or an if statement for fallback assignments. Building on the null coalescing concept, C# also provides the null coalescing assignment operator question mark equals. This operator offers a convenient shorthand for assigning a default value to a variable only if that variable is currently null. For instance, my variable question mark equals initial value will assign initial value to my variable only if my variable is null at the time of the assignment. This is particularly useful for lazy initialization patterns or ensuring that a field or property always has a non-null value after its first access, making your code more compact and expressive. C# also offers modern pattern matching capabilities that provide a clear and expressive way to check for null values. Using as null or as not null for null checks is often preferred over traditional equals null or not equals null comparisons, especially when dealing with nullable value types or when you want to leverage the full power of pattern matching. For example, if object is null or if object is not null clearly communicates intent and can be integrated seamlessly into more complex pattern matching expressions, enhancing both readability and type safety in your code. In summary, C# null safety features, particularly the null conditional operator question mark dot and the null forgiving operator exclamation mark, are indispensable tools for writing more reliable, maintainable, and robust code. These features, alongside nullable reference types, empower developers to proactively address null-related issues at compile time, shifting the focus from reactive debugging of runtime errors to preventative design. By understanding and correctly applying these powerful constructs, you can significantly elevate the quality and stability of your C# applications. By diligently understanding the nuances and correctly applying these operators and other null safety features, you can dramatically reduce the occurrence of null reference exceptions in your applications. This proactive approach not only prevents frustrating crashes, but also leads to more predictable program behavior and a better user experience. Embracing null safety allows you to build more robust, production-ready applications that stand up to the rigors of real-world usage, fostering confidence in your software's stability and performance across various scenarios and data inputs. Ultimately, embracing null safety in your C# development workflow is a commitment to writing cleaner, safer, and more predictable code. It's about leveraging the language's capabilities to build applications that are resilient to common pitfalls and easier to maintain over time. By integrating these practices, you contribute to a higher standard of software quality, reduce debugging time, and deliver a more reliable product. Continue to explore and apply these principles in your daily coding. Happy coding, and may your applications always be null safe.